All right, let's dive into one of the absolute wildest ideas in all of modern physics. We're talking about a potential link between two of Einstein's strangest predictions, a connection that could totally reshape our understanding of the universe.
So let's just start with this one mind-bending question. What if two tiny particles, even if they're on opposite sides of the universe, were secretly connected by a tunnel? A tunnel burrowing through the very fabric of space-time itself. Sounds like something straight out of science fiction, right? Well, it's a very real possibility that physicists are wrestling with as we speak.
Our whole story really kicks off with this idea of a spooky cosmic connection. It's a conjecture, an educated guess, known by the simple and kind of mysterious name ER equals EPR. We're going to break down exactly what each piece of that little equation means, because when you put them together, well, they might just solve one of the deepest paradoxes in all of physics.
Okay, first up, the EPR part. This stands for quantum entanglement. You've probably heard of it. It's what Einstein famously called spooky action at a distance. And it's not a theory, it's a real thing we've observed. You can link two particles together, and if you measure a property of one, you instantly know the same property of the other. And I mean instantly. It doesn't matter if it's across the lab or across the galaxy. It's a connection that seems to completely ignore the cosmic speed limit.
Now for the ER side of the equation. This stands for an Einstein-Rosen bridge, which we all know by its much cooler name, a wormhole. This is a purely hypothetical idea, a shortcut through spacetime. Imagine spacetime is a giant sheet of paper. To get from one side to the other, you'd have to travel all the way across. But what if you could just fold the paper over and poke a hole straight through? That's the idea of a wormhole, a tunnel connecting two incredibly distant points. So you have spooky, instantaneous connections, and you have hypothetical tunnels through space. Then in 2013, physicists Leonard Susskind and Juan Waldacina dropped a bombshell. They proposed that these two bizarre ideas aren't just kinda similar, they might be the exact same thing. The ER equals EPR conjecture says that every single pair of entangled particles is actually connected by a tiny, microscopic wormhole. That spooky action? It's not some weird, faster-than-light signal. It's just a message taking a shortcut through a private tunnel. Okay, so why does a radical idea like this even matter? Where does it get tested? Well, you have to go to the most extreme place we know of in the entire universe, a black hole. This is the place where our physics just breaks. And it's here that this wild idea about entanglement and wormholes might actually be the only thing that makes any sense. See, the problem with black holes is that they are the ultimate battleground for our two greatest theories of the universe. You've got general relativity, that's Einstein's theory of gravity and the smooth fabric of spacetime, and then you have quantum mechanics, the theory of tiny particles and information. Both of these theories are incredibly successful, but when they meet at a black hole, they give completely contradictory answers. They just can't both be right. This massive conflict, this paradox, it led some physicists to propose a solution. And it's a radical and incredibly controversial one. It imagines a very, very violent end for anyone who tries to cross into a black hole. It's an idea known simply as the firewall. The firewall theory just completely torches our old picture of a black hole. It says that the event horizon, that famous point of no return, isn't some invisible, peaceful line you cross. No. Instead, it's a blazing, raging wall of high-energy particles that would instantly incinerate anything and everything that tries to pass through it. So, for decades, the standard view was that falling into a black hole would be surprisingly gentle at first. You'd drift across the event horizon without even noticing. The firewall theory says, nope, not a chance. The very instant you touch that line, you hit a wall of pure energy, and you are just gone. As you can probably imagine, this idea didn't exactly get a quiet reception. It kicked off one of the biggest, most heated debates in theoretical physics in recent memory. This is a genuine controversy, a scientific argument that's happening right now at the absolute edge of what we know. So, this firewall idea was put forward in 2012 by a team of physicists. And they weren't just trying to be dramatic, They were trying to fix a deep, nagging mathematical problem with how information is supposed to behave around a black hole. But their solution was so extreme that the physics community is still fiercely divided on whether it could possibly be the right answer. And this isn't some new problem that just popped up. The core ideas, the entanglement paradox and wormholes, they were both first proposed way, way back in 1935. It just took decades for the full depth of the problem to come into focus.
And this whole firewall debate is really just the latest, most shocking chapter in a puzzle that's been cooking for nearly 100 years.
So, what's the point of all this? A debate about firewalls and wormholes? Why does it matter? Well, it matters because it forces us to ask the biggest, most fundamental question there is. What is reality actually made of? And that really leads us to the final, lingering question at the heart of all this. Is space-time, this three-dimensional fabric of the universe that we live in, is it the fundamental stuff of reality? Or is space-time itself just an illusion, something that emerges from a deeper, stranger reality, a reality built out of those spooky quantum connections? The answer, whichever way it goes, could rewrite everything we thought we knew.
Honestly, this is a debate that is so far from being over. If you want to dive in a little deeper and play around with these ideas yourself, definitely check out the interactive resource we've linked in the description. The universe might just be a whole lot stranger than any of us can possibly imagine.